Hello. Today we're going to be doing 2.4, which is describing proportional relationships and the constant of proportionality. So today we will learn how to use the constant of proportionality to represent a proportional relationship. So this is everything that we've already been doing. So the constant of proportionality is our unit rate that we've been finding the last few classes. Okay, so remember, unit rate, you just divide. So the constant of proportionality is the constant multiple that relates proportional quantities x and y. So it's the same thing we've been doing, we're just taking it one step farther. And the constant of proportionality is represented by the letter k. So you can see here, it says k equals y over x. That's exactly what we've been doing with our tables. Okay, so like if you look at this first example, it says y divided by x. That's exactly what we've been doing to find our unit rate, and that's exactly what we're doing today. We're just calling it constant of proportionality now, or k. Okay. One thing I want to make sure you know, so if you have something that looks like this, you want to change it so that the y is by itself like that. Okay, so we are going to have y equals kx on all of these. It's going to take a little bit to get the hang of this, so do not freak out. Okay, but so if we had, let's say, 5y equals 2, I'm going to change that, just kidding. Let's do 6y equals 2x. If we have something like that, okay, well, we need to get the y by itself. So we want it to look like this equation. So we want to get the y by itself. So how do we get rid of the 6 on the left side? Well, to get y by itself, we have to divide. So I draw my line, and I would divide by 6 on both sides. And that means that's gone. And we'd be left with y equals 1/3 x. Because 2 divided by 6, you could either leave it as a fraction, which would be 1/3, so we simplified it. Or if you actually divided those, it would be 0.3 repeating. Either one would be okay. And then k is 1/3. So our constant of proportionality is 1/3. So what we're going to be doing is finding our constant of proportionality from different tables and then making an equation out of it. And the equation always looks like this. It'll make more sense as we go through these. Okay. So it says write an equation to represent a proportional relationship. So this is showing us hours and liters, which is x and y, and we want y over x. We always put the y on top no matter what. So our y is 8, and our x is 10 for the first one. And then on the second one, our y is 12, and our x is 15. So you can either leave that as a decimal, you can leave it as a fraction, or you can change it to a decimal. Okay? So if we wanted to leave it as a fraction, that would be, we would divide them both by 2, and we'd get 4/5. And if we wanted to change it to a decimal, we would divide those. You'd do 8 divided by 10, and we'd get 8/10. Okay? So either one of those would be correct. It does not matter which one you use. Okay? So then for 12 over 15, if we divided both of those by 3, we would still get 4/5, which would also be 8/10. So you still have to divide, you still have to find your unit rate, so y divided by x, to make sure that the table is a proportion, to make sure it is proportional. So since we got the same answer for both, our k, you can either write 4/5 or 8, it doesn't matter, or 0.8. And then our equation, we just plug it in, so it'd be y equals 4/5 x would be our equation. And that's it. That's all we're doing. So on this one, we're going to do the same thing. So just make sure you remember, it's always y over x. Okay, that's a big mistake that I see students make, but y is always on top. So for this one, we'd have 30 over 3, 80 over 8, 100 over 10, 60 over 6, and then 70 over 7. And then we have to simplify those. So 30 divided by 3 is 10. 80 divided by 8 is 10. 100 divided by 10 is 10. 60 divided by 6 is 10. And then 70 divided by 7 is 10. So they all equal 10. So our constant of proportionality is 10. So that means k equals 10. And then our equation, we just do y equals 10x, because our k should always be right before the x. And that's our answer. All right, you pause the video, try this question on your own, and then you can fast forward to see if you got it correct. So Maria made 2 batches of fruit punch. The table below shows how many quarts of juice she used for each batch. Write an equation and then find the constant of proportionality. So it's still y over x. So our y on this first one is 8, and our x is 5. And then on the second one, our y is 16, and our x is 10. So now 8/5 is already simplified, so we can keep it like that. I'm not going to change it to a mixed number. We're not going to change it to a mixed number on any of these. They stay like this, as improper fractions. Or you can change it to a decimal. So if we change this one to a decimal, this one is tricky because it's repeating, so it'd be 2.6 repeating. And so in this case, I would probably stick with the 8/5. Okay. And then 16/10, if I simplify that, it would be 8/5, because I would divide them both by 2, or 2 and 6/10 repeating. Okay. So that means the simplified version is 8/5. Okay. So that's what I'm going to use as my k. You can use the 2 and 6/10 repeating, but if it's repeating, I usually keep it as a fraction. So we'd have our k equals 8/5, and then our equation is y equals 8/5 x. All right. On these ones, we're going to solve the problems using an equation. So it says 1 inch equals 2 5400 centimeters. How many centimeters long is an 18-inch ruler? So it says write an equation to represent this relationship. So to be able to convert, okay, it shows us that 1 inch equals 2.54 centimeters. So our equation is going to be y equals 2 5400 times x. Because 2 5400 is our constant of proportionality. It's our k. And then if we want to use the equation to find the length of the ruler, well, 1 inch equals 2.54 centimeters, and we want to know how many centimeters long is an 18-inch ruler. So we have to plug 18 into our formula, and that's going to be x. So we're going to do y equals 2.54 times 18. So we're plugging it in for x to figure out our answer, and that'll get us what y is. So in my calculator, I'll do 2 5400 times 18, and we get 45 72 hundredths inches. And that would be what y equals. So once you have your equation, you can solve it for anything. If we wanted to know how long a 2-inch ruler is, we would do 2 times 2 5400. If we want to know how long 10 inches is, we would do 10 times 2 5400. So once you have your equation, you can plug any numbers in that you need to. All right, on this next one, it says a florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. How much would 18 roses cost? So it says write an equation to represent the relationship between the number of roses x and the total cost of the roses y. So this is very similar to, like, if you guys were setting up a ratio table, we'd do $35.40 over 12, because it says that's how much it costs for a dozen roses. And we'd want to figure out how much 1 rose costs, and then figure out how much 18 roses cost. This is very similar to that, but now we're shortening it and just making it into an equation. So this is what we want. Okay, that's our starting rate. We want to simplify that to change that to figure out how much 1 costs. So that's why we divide. That's what we're figuring out, is how much 1 rose costs. So if we do, because our K equals, well, okay, so we have $35.40 for 12 roses. We want to know how much it costs for 1 rose. So we're going to divide to get 1. So $35.40 divided by 12 is $2.95. So that's how much it costs for 1 rose. So our equation is going to be y equals $2.95 times x. That's our equation. So your constant of proportionality, that K, is always the unit rate, okay, or the unit cost, however you want to look at it. So it says use the equation to find the length of the ruler in, oh, that's not right. That should say we want to know the total cost of the 18 roses. Okay, so if we want to know how much 18 roses cost, we got to plug 18 into our equation. So we do y equals $2.95 times 18. So $2.95 times 18 would get you 53.1, which I'm going to add a 0 because we're talking money. So for 18 roses, it would cost $53.10. So keep in mind, we did exactly what we did for our ratio tables. We divided to figure out our unit rate here, and then we multiplied by 18. So this is just another way to solve it using an equation instead of a ratio table, because the equation will come in handy in the next few lessons. Okay. All right, flip your page over. So this next question says, in a certain chemical, the ratio of zinc to copper is 4:11. A jar of the chemical contains 319 grams of copper. How many grams of zinc does it contain? So we want to create an equation and then solve it. So first we got to find our K. Okay. Our K is our ratio that it gives us, 4:11, and I'm going to write that as a fraction. So if K equals 4:11, that means our equation is y equals 4/11 x, like that. And then if we want to know if the jar of the chemical contains 319 grams of copper, how many grams of zinc does it contain? We got to plug 319 grams into our equation. So that's going to be our x. So it's going to be y equals 4:11 times 319. So I'm going to put that in my calculator. I'm going to do 4/11 times 319. And we'd get y equals 116. And it would be 116 grams of zinc would be our label. Okay. All right, a few more. So example 3 says, determine whether y equals kx describes the situation. So we can only use this equation when our table forms a proportion. So if our table is not proportional, that means we cannot use the equation. Okay. So it says, can you represent the total cost y for admission and x rides at the amusement park using an equation in the form y equals kx? So it tells us the cost is y and the rides are x. Okay. So if we look at our little picture over on the left, sorry, it's a little blurry, we want to figure out what is the cost of one ride, or how much it costs in total for us. So if we ride one ride, that's $5, but it costs $20 to get in. So our admission plus one ride would be $25. To ride 2 rides, so 2 rides would be $10 plus the admission, that's $30. For 3 rides, that would be $15, and then plus admission, that would be $35. So now we need to figure out if our table is proportional. So I would do our y divided by x, so 25 over 1, 30 divided by 2, 35 divided by 3. And I'll put those in my calculator to solve. And they have to equal the same thing for it to be proportional. So 25 divided by 25, or 25 divided by 1 is 25. 30 divided by 2 is 15. So I already know that it's not proportional, but I can do 35 divided by 3 just to be sure, and I'd get 11 and 6 repeating. So we would say, no, the table is not proportional, and so we can't use the equation. If we did use the equation, it would be y equals 5x, because that's how much it costs per ride, and then it would be plus 20, because that's how much the admission costs, and that doesn't change. So then if we put a 1 here, it'd be 5 times 1 is 5, plus 20 is 25, which gets us our first answer. If we put a 2 there, 5 times 2 is 10, plus 20 is 30, so that gives us the second one, and so on. So that's why this is the correct equation, but if it has anything extra other than the y and the k and the x, it is not proportional. Okay? All right. We are going to skip this one. So yeah, you don't need to worry about that one, but let me know if you guys have questions, and we will go over this more tomorrow in class.